Well, hello everyone and welcome to this morning's webinar. Thank you for joining me. My name's Matt Locke. I'm the Business Area Manager for Rail and Monitoring for KOREC in the UK. Today's webinar is being recorded and will be available online later for you to review. And you'll also get a link to share that as well with any colleagues that might be interested in viewing this at their leisure. We'll also have an opportunity for questions at the end, so if you want to type any questions as we go into the questions box, and I'll do my best to answer them as once we finish the main section of the webinar. So today I really wanted to update you on some of the rail solutions that we have on offer and discuss how they may be a benefit to you guys, particularly as we head into CP6 this year. Our industry is constantly evolving, and as we all strive for greater productivity and improved safety on a busier and busier network, while also keeping in mind the costs involved, technology really will be a key part of helping us meet our goals. And also the latest technology is attractive for the next generation of rail engineers to use as well. So we want to make our industry as attractive as possible to the up and coming rail engineers that we also desperately need, and of course keep them in the industry. So I thought I'd start by sharing with you some of the changes that we've made at KOREC. We implemented these at the beginning of 2018, really with a view to improving our customer engagement. So essentially as a business now, we're split into regional teams. Each region has a sales director who's responsible to our boards to look after that particular region. And as part of his team or her team, they also have salespeople and field support people as well. So they're running as a complete unit, if you like. Then alongside those are business area managers like myself. My colleague Richard Gorshman looks after our mapping and GIS business area. My colleague Simon Harley looks after our construction side and our third-party companies. We also have a hire business area manager, that's Mr. Mark Crawford, and myself looking after rail and monitoring. Behind all of us, we have our key operations teams, and they include sales support people, the team who deliver the hire equipment, our service team as well that look after all the equipment in our Dublin and Huntingdon office. Logistics guys, of course, very important to make sure that kit's delivered on time. And we also have office-based support staff as well as the field-based support staff who also help us with on-site training as well to help you guys get the most out of the kit once you've purchased it or hired it. So the service team really is very important to us. It's very important that we react quickly to customers in the UK. With that in mind, the team in Huntingdon have the first Trimble certified GEDO technician worldwide, and we will be doing some further updates on our premises in Huntingdon later this year, which we hope will improve things still further. And the support team, as well as doing bespoke courses for customers designed to help them get the most around the kit that they've purchased. We also run scheduled training courses for things like general survey refreshers, introduction to topographical surveying techniques, that kind of thing as well. So do look out for our timetable of scheduled training courses throughout the year. With that in mind, one of the changes that we've made this year is to have my colleague Tom Williamson focused on rail. He's going to look after the rail business area from a support, training and extended warranties point of view. And the idea really is that Tom's worked quite closely with us in rail over the last few years, but to really increase the customer engagement program really with particularly with the GEDO system. So we'll be offering training courses, update and refresher courses. We're talking to you about extended warranties and the benefit of that, and also training new teams. So rather than customers having to rely perhaps on cascade training, we'll be able to look at scheduled timetable training courses to help get new members of the team on board and using the kit more quickly. And as part of that training program, we also put together training material like videos, manuals, quick guides, that kind of thing. And we also go through a test at the end of that, so that we know that everyone that passes through the course is competent in using the kit going forward. So that's great news for us that Tom's on board as a focused rail applications engineer, and he'll be working very closely with me throughout the UK. Also, some of the events, excuse me, that we'll be attending during 2019 will be at RailTex in May. We'll also be back at Rail Live this summer. It's always a good event. I do really recommend you attend if you can. Couple of days of outdoor activity, got plenty of kit on show, and it's an opportunity to see a wide range of rail equipment out very often in its active environment. We'll also be doing a number of KOREC events this year. We ran some Trimble Express shows last year. We'll be doing that again during 2019. The first one is up in the northeastern region near Leeds at Hazelwood Castle on the 13th of March. So please do visit the website and sign up for that. With a view to our online presence, the website is certainly the place to go to get all the latest information. We also have a YouTube channel as well. So as I said before, this video will be on our YouTube channel. We have a lot of how-to guides and user guides going on there, as well as various webinars that we've run over the years. So do recommend that you guys visit that when you can. We're also on the usual social media sites, Twitter, Facebook, Instagram, and LinkedIn. And with that in mind, we've had a LinkedIn group for some time now, the Rail Infrastructure and Track Maintenance, over 300 members. So do encourage you to sign up to that. We will be using that as a forum going forward much more actively as well from this year. Also, GDPR is very important for us. We can't keep in touch with you guys unless you ask us to. So please do sign up. You'll see various links on our websites and in our email signatures. You see the link on the screen there. So please do go ahead and sign up for GDPR. It's not we're not going to bombard you with sales information, I promise. It's as much to keep you up to date with events like this, training programs and offers as much as anything else. So please do sign up. Okay, so if we think about the rail as a life cycle, we have a number of different hardware and software solutions that we can offer, from feasibility, design, construction, safety, and maintenance. So really, the rail is not an end-to-end solution. It's a continually revolving life cycle, and we like to think we have products that fit into all of those different areas. You can see a little antenna up here on the right hand side. This is something that's been out a year or so now. This is from our mapping division. My colleague Richard Gorshwin has had great success with this over the last year or so. And this is a subscription GNSS receiver that can plug into a smartphone. So we've seen a huge amount of applications for this particular product. Although I'm not going to cover that in detail today, I recommend you check out some of our YouTube videos, particularly around the GIS side, and see how we can help you from that perspective. If any of you are using pen and paper and would like to streamline that process, our GIS solutions are the place to go. So this morning, really, I'm going to focus on the survey element and how we can offer some improved productivity and smart tools to help you get the most out of the data that's captured. And really, that's going to sit around the feasibility, the design, and the safety and maintenance when we're looking at that particular life cycle. I'm not really going to focus too much on construction today, although we'll probably touch on a couple of things around that. So we're familiar with the conventional rail survey, total station on a tripod measuring to a target on a rail shoe. That's allowing us to measure the running edge of the rail and the track geometry. We can move on from that and start using a Gedo track measuring device. This has sensors on board to measure the cant and gauge. So when we place a prism on there, we can generate the rail geometry much more quickly than using a rail shoe. and also much more precisely because the sensors are taking account of the track geometry as we're measuring. And we can also then add additional sensors to that track measuring device, in this case a 3D laser scanner, and from there we can start to get much more rich information, point cloud data, as well as track geometry information. And this is really key when we're looking to maximize our time on site. So if we think about taking profiles of tunnels or structures, capturing point cloud data allows us to be able to view the whole of the site in very high accurate detail, and cut cross sections wherever we like, take measurements wherever we like, and capture that data much more efficiently than we would do with manual measurements. Once we've got that data, we can run various algorithms within the software, and that's what I'm going to touch on a little bit later on in this presentation. We'll do a live demo through some different data sets to show you examples of what we can do. But as you can see, there are real tangible benefits to having point cloud data. This is on Network Rail's media center, where they've been able to use 3D point cloud data to check clearance, to introduce new rolling stock much more efficiently than would have perhaps been possible in the past. So the first update I'd like to talk to you about is sits around the Gedo track measuring device. Very proud to have been associated with the Gedo for a number of years now. In fact, it's the 10th year this year in 2019 that we first started working with the Trimble GEDO, and it gained Network Rail approval, is Gedo 1. The Gedo 2 came along towards the end of 2012, beginning 2013, and that's the device that you can see on the screen there. And the idea really with the Gedo 2 is to make it as flexible as possible, so we can add different sensors to the same chassis to help maximize your investment in the equipment. We can also change the gauge adapter so that the Gedo can be used on gauges from 1 meter upwards very, very easily, just with the introduction of the gauge adapter. We also do a bespoke Gedo, which is available for narrow gauge track, and if required, Trimble are very flexible in terms of modifying the system. So for things like embedded track, or if you're looking to set out slab track, for example, we can modify the Gedo to meet your particular requirements. But even so, we do face some challenges using conventional survey techniques out in the field. First of all, we have to factor in time to set the total station up. Obviously, we want to be on site for as little time as possible. We don't have much track access time, so we need to capture as much as we can, as quickly as we can, and setting up and orientating a total station, particularly on a tripod, can take some time. We can move that on a bit with the twin system that you can see at the bottom right-hand side of the screen. The setup time to the instrument is significantly reduced, but we still face challenges on some sites even with a system like that. Line of sight can be a potential issue if we've got people in between track measuring devices, or if they're getting in the way of a total station set up in the set on a tripod. Refraction and environmental conditions, of course, play a part as well. If the ballast is very hot, it gives off, it's very good at trapping and retaining heat, and then you'll get heat shimmer, which means you need to reduce your observation distances between the instrument and the prism. So that's something to bear in mind, particularly through the summer months. Then we need to think about track access and the number of protection staff involved. Working at night, obviously more and more people would prefer to work during the day, but there are occasions when we have to work at night to be able to gain the access that we need. And reference control points are needed along the track, and sometimes those control points get demolished as well. So for the engineering teams coming up behind the surveyors, trying to tie into existing control can very often be a challenge. So we need to think about that as well. And as I mentioned before, we need to measure as accurately as we can and as quickly as we can. So one way that we can improve those conditions is by using the Gedo IMU. IMU stands for Inertial Measurement Unit, and we add that yellow box there that you can see onto the side of the Trimble GEDO 2 track measuring device. Inside, it has a series of very high precision gyros and accelerometers, and it acquires the data at very high rates. So effectively, the system will initialize when you first turn it on. It's then working out its position and its orientation. Then when you start pushing the track measuring device along, the system will track its 3G trajectory and effectively allow you to do away with a total station. There's a PC embedded in there as well. The initialization time that I mentioned is very fast though, so it takes less than 6 minutes for the system to compensate and initialize. Runs with standard S-series batteries that you can see on the image on the right hand side there. Those batteries will go in the total station, they'll go in the Gedo itself to power that, and they'll also power the IMU, so it's just one battery system to consider. And very lightweight, so the IMU itself weighs less than 6 kilograms. Now, when we're out in the field, IMUs over time do have the propensity to drift, so we do need to correct for any drift in the trajectory as we go. So the system that we see here also has a profiler on. So this section here is a laser tape on an angle encoder, so we can measure offsets to points as we go along the track. So we start off in the field by parking the Gedo opposite a reference point. The profiler has a visible laser spot, so we can measure that reference point very accurately. And then we can proceed along the track. And as we come to more and more reference points, we just measure those as we go by. We can also, though, as we're traveling, measure other information with the profiler. So if we've got a topographic point which might need to be captured, like a fence line or a datum plate, position of a lockbox, etc., we can measure topo points as we go. And we could also use those for reference points in the future. So if we were going out on site and we had some control missing, we could add to that existing control as we pass. That's very helpful for the construction guys coming along behind the survey team, as I mentioned before. And then when we get to the end of our survey area, we just take our final end reference point, save the file, and that's job done. So that's using the profiler to capture track geometry in the field. We can also actually have the design alignment in the background as well, and see where we are against design. So we can do a design validation survey while we're out on track as well if we wish. The next thing we can do is combine GNSS technology with the profiler. So if we're in an area where there might not be any physical control points, we want to tie into a GPS grid for some reason, we can use either a VRS-based system where we have real-time corrections coming from Ordnance Survey base stations, or we can use a local site coordinate system with a GPS base station, and then use the Gedo as a rover. So in that situation, we would start the system off by taking a GNSS position, and then as we move down the track, we can take intermediate GNSS positions. Because we have the profiler on board, we can also measure topo points or add control points in if we wish. And then again, once we've finished our run, we can end the survey, store the data, and away we go. We can also add a scanner to the system, and this is where it becomes very much more productive. So here we have, we don't need to stop the Gedo and take any measurements. We just walk along the track and measure the targets. And you can see some of the targets on the left-hand side here. We've got them with a bubble and a 5/8 thread and a point, so that we can use this as an ordinary detail pole target. We also have them that can be mounted on OLE gantries as well as we pass. And we have reflective stickers that you can attach to walls and things like that. So as you push the Gedo system along with the IMU and the scanner running, you'll pass the targets. That will then allow all the information to be synchronized and processed in the office via Gedo Scan Office software and Gedo Office software. So benefits of the IMS, first of all, high productivity. Depending how fit you are, you might get up to 5,000 meters an hour, but realistically, a good steady walking pace without having to stop or set up an instrument allows significantly greater productivity than you'll get with conventional instrument-based systems. No impact, or reduced impact rather, due to the environmental conditions, particularly with refraction, which is our biggest issue, and also no line of sight problems either. Very high density of points along the track. The IMS system is running at 200 Hertz, so we get a lot of data. Fully integrated into the Trimble family as well, so we can add on the GNSS profiler and laser scanner to the system as well. Allows the Gedo to be used in new applications, particularly if you're in areas where there's very sparse control or no control at all. You can at least get some work done. And improve safety, very key for us. So only one person is required to operate the system. Although depending on the accessories added onto the Gedo, you might want to have a second person in attendance to remove it from track. Lightweight and fast to initialize, so you can begin work very quickly with this system. Like I say, initialize within 6 minutes and you're ready to go. So the kit basically consists of a new Gedo TMD, which is IMU ready. It is slightly different to the original Gedo chassis. All been network rail approved now though, so the full Trimble solution is network rail approved. The Gedo IMU, of course, tablet computer, because we need higher processing power to run the data. We also support the new T10 tablet, which you can see on the right there, and the new TSC7 controller, both of which are Windows based. The TSC7 is a really nice controller, very powerful, very high quality screen, and backlit keyboard as well, which is particularly important for us working at night. And then we also get updates to the field and office software. So the field software, nice and easy to use, that goes on our TSC7, T10 or tablet controller, and then we get a new module for Gedo Office to process the IMU data. I will just quickly touch on rail monitoring. There's a number of people now looking at scanning for a way of monitoring tunnels, but also within the Gedo Office software, we do have a monitoring module, which allows us to be able to compare different survey runs on the track and generate reports. That's actually part of the Gedo quality module and is available in the latest versions of Gedo Office software. Moving on with the scanning point of view, I also wanted to touch on the Trimble MX9. This has been around for just under a year now. We've had our system up and running for around 9-10 months, and we've been able to access it for use on the track as well. So I'd like to share some of that data with you and some of the processes involved. So this is the forerunner to the MX8, to MX9 rather. This is our MX8. You can see the MX8 box here up on the roof of the vehicle, and then you can see the computer system which sits inside. So the MX8 was very much a dedicated system. You couldn't move it around vehicles very easily at all. So although you had good quality data, it wasn't as flexible as we would like. Enter the MX9, and you can see it's a completely different scenario now. So we've got it on a roof rack system, and then to drive it, we can operate the MX9 through a tablet or laptop. Basically, the MX9 consists of the device itself. So we've got two high-speed laser scanners measuring 2 million points a second. We've got a high-end IMU GNSS system on board to give high-quality positional data, very best on the market. We've also got a series of cameras as well. So we've got the spherical camera at the top there, forward-looking and rear-down cameras as well. We have a roof rack system, which allows us to mount the MX9 onto the roof rack extremely quickly, just clicks into place and locks. And the roof rack can be easily mounted to a wide variety of vehicles. We have the power unit that runs the device through that umbilical cord that you can see come out of the MX9 there. And we have the control unit, so that's where all the data is stored. That's where we have removable solid state drives as well, and that gives us the connectivity then through to the control unit, which, as I say, is really flexible. Tablet, laptop, absolutely no problem to run the system. And then finally, we can add some accessories which will help in difficult environments, particularly tunnels. We have a GAMS antenna and distance measurement indicator, which can also be put onto the vehicle. This is what it looks like then when it's fitted. So we went out and did some survey work on a piece of track local to me with the MX9. You can see it fitted onto the Land Rover there, just on a conventional roof rack mounting system. And took us around half an hour or so to get that put on and configured, and off we go. You can see examples of the point cloud there. So these are colorized from the data. We can have just intensity values, but in this case, the team have chosen to color the point cloud just to help people understand a little bit more easily. And part of the benefit really with the system is the ability to mount or to adjust the twin scanning heads. So we can run the lasers at different speeds, but we can also adjust their position. And that gives us what we call high fidelity data. So this is the scan from the left laser, this is the scan from the right laser, and then this is the combination of the two. And you can see you get much more highly defined information, and you get some really nice straight line striping there as well, very close together. So a very, very good quality point cloud, which enables smart algorithms in software to be able to do a lot of automated processing. And that's really what we want to do, because we're going to drive the data quickly, want to be able to get out and extract the information we need quickly as well. The better the data quality, the easier it is for smart algorithms to be able to help us get that data out quickly. We've also, of course, got the imagery, as I mentioned. So you've got the 360 spherical camera. You've also got forward-looking and rear-down cameras as well. And then we can start processing the data using a combination of the point cloud and the imagery, and start extracting asset information as well as digitizing data as well. Very intuitive software that we run from Trimble, easy to get to grips with, and very, very productive as well. So you really are, with this system, taking the field into the office, and you can capture data from it at your leisure. So the workflow would be collect the data with your tablet device in the field, process that information through Trimble's POSPAC software to get your trajectories, and then we want to model and analyze that data. So we can go into Trimble Business Center, which is our survey and engineering package. All our data can be brought into Trimble Business Center, from digital level and traversing right through to MX9 data, SX10 mobile scanning data. It can all be managed through Trimble Business Center. And then if we're looking for asset extraction, GIS mapping type applications, then the Trimble MX software is perfect to be able to get data in the format required for those markets. And of course, GEDO Scan Office can also accept data from the MX9. And to that end, we went out and did our rail survey. So this is the MX9 mounted on the Land Rover, ready to go. We also had the Gedo IMU scan system available as well there to go out and capture the same data, because we want to compare the two measuring systems. And to give you an idea, that's what the elevation difference is between the two. So you can see the Gedo at track level there with the TX8 laser scanner on board, and then you can see the MX9 mounted quite a bit higher up. And these are the data sets to compare. So this is in GEDO Scan Office software. You can see this has actually come from the Gedo track measuring device. The blue lines there indicate the track geometry surveyed by the Gedo IMU system, and you get a very good quality point cloud, but you can see some shadowing because of the height of the scanner above the rail. Compare that with the MX9, and you do get a very much richer point cloud because of the height on that particular system. And actually, I was very surprised by the minimal shadowing. You're just missing areas under the lip of the platform there, which is unsurprising due to the height of the scanners. But a really high quality point cloud data. And comparisons between the two systems were really, really good. We also compared them to platform gauging as well, and had results typically 20 million better. So with that in mind, we talked about productivity. The boots off ballast is a requirement for the industry. Survey fast and use many times. So just to compare the various systems, this was a conventional scan we did a couple of years ago, where we set up conventional instruments, measured a single bore, saw single track tunnel, and that took around 4 hours with 5 instrument setups and a couple of people. Contrast that with the IMS on this particular project, 1,250 meters in 42 minutes. Again, we did have 2 people there to assist in lifting the kit off, so 1 operator, another person to help lift the system off track if required. But you can see a huge increase in productivity using the IMS. And unsurprisingly, using the MX9, basically as fast as you can drive, we can operate up to 110 kilometers an hour, I believe, with the MX9, and still achieve very high quality point cloud data. But what are we capturing this data for? Well, and how do we share this data around? A platform that we have within the Trimble family is Trimble Connect. This is an online system which allows us to share data between the field and the office, but it also allows us to share project information with different disciplines. So we have the surveying side, the construction side, buildings, BIM, MEP, etc. One Trimble Connect project can contain multiple layers of information. To give you an idea of what Connect looks like, I can run a live demo on it if we have enough time this morning. But just to give you some screenshots, once you log into your Trimble Connect account, which is free to set up, and I encourage you to speak to your local reps or to go online, search out Trimble Connect and set yourselves up with an account. If you're Trimble users, you'll be able to do that, and you'll be able to synchronize your data, create your projects, and be able to push that data from the controller to the software via the cloud immediately. So this is my particular account. So I've got a couple of projects in there at the moment. If I click on one particular project, for example, I can see the BIM model. In this case, it's associated with it. This is data from Trimble's Tekla business, but we could also have BIM models in here from Autodesk or from Bentley Systems. And the data is layered here, so we can see the different layers, and we can visualize those different layers by clicking on the eye. And then we also have the ability to create different views, add to-do lists, check clashes, and even make measurements and add text and information within that particular project, so that anybody that's also invited to share data around that project can see what our concerns or what our comments might be. Another way of viewing the data, which we're really excited about, is using the Microsoft HoloLens to do so. That's using, this is the HoloLens actually in operation. So this is what the user sees when they're looking through the lens. So the first thing that the HoloLens does is map its environment. So you'll see some grids appear in a moment. So we've opened that particular project and we want to view that 3D model. And we're now just in a boardroom environment and we're connected to the internet. So one person can actually see this and operate on it, but if we have multiple users in the room with headsets on, they could all see exactly the same thing and all have input around what was going on. So the user is going to scale the system, pin it to the desk and scale it. And indeed, if users were in different offices, as long as they had internet connection, then they should be able to also view and work on data. So we'll see this model come in now and then get scaled and moved around the room. And of course, we have the same control over this through the HoloLens as we would do in Trimble Connect. So we can turn on and off different layers. We can move to different areas. We can measure things if we wish, dimensions of bridges. We could look at the rebar in the structure, all that information can be viewed and shared really easily with the team, as I say, either in the room or potentially remotely. So that's an overview of how Trimble Connect works and how the HoloLens works. I'm conscious of time, so I'd like to just talk to you now about some of the smart algorithms that are available in GEDO Scan Office. I've just got a variety of different data sets that we can walk through, and I can show you how some of those features work. So that's the contact details for Tom and myself. Please don't hesitate to get in touch with either one of us if we can be of any further assistance. Thank you for your attention so far. Hopefully your warm beverage is still warm, and we can just run through now some data sets with GEDO Scan Office to share some of the new functionality with you. Okay, so this is the GEDO Scan Office software. When it opens up, we have our recent files, or we can just create or open a project. GEDO Office allows us to do all the processing of the scan data. So if I open up this particular project, you can see here up in the left-hand side, this is our project tree. So this shows us the different tracks that we have. It shows us the laser scan measurements that we have. And it also shows us what we call our 3D analysis, and that sort of combines the tracks that have been measured and also the different laser scans that are pertinent to the particular project. So at the moment we're hinged to the track. We've got our tools at the top here, so we can change our different views. We're toggled to the track at the moment, but we can go into freeze zoom mode if we wished. We can also look at the track in section mode as well. So as we wheel through, we can see the cross sections growing there if we wish. We'll just run it in perspective for now. And at the bottom here, we can see our current chainage as well. So what I'd like to show you in this particular data set is the shape tracing tool, which is the one just here. So if we come down the track a little way and have a look at the platform edge here, I can choose the shape tracing tool. That then allows me up here, we work through these in step by step. So I can choose whether I want to project a left profile or a right profile. So I can just mirror that, and that's in direction of positive travel, so back to low mileage. I can choose the different shapes, so we can create the shapes either manually or we can import DXF shapes. We can choose the selection mode, so an automatic, and what distance we want the points to be generated. So what I do now is if I click on the platform edge, it says confidence here of 99.3%. So I can just now accept that point. Now it's going to advance a meter. You can see here that the coordinates of that point have been created along with its chainage. So I can just accept the next point, and the next point, and the next point. And as we go along the platform edge here, you can see this blue line being created. And we've actually got these coordinates now, so I can carry on digitizing from the cloud. We can see here that we're very high confidence limit still, and we're actually generating this red point here. So we're generating the platform edge, the hidden point. Once we've captured the data, we can then add them all to the registered points. So if I click on that, those points now sit inside that project, and they're up here under registered points. I could also, if I wish, choose export. So if I click on that, I can export all the measurements, click OK, and I go to a comma separated file. So I could say platform, click save, and that's a CSV file of all those coordinates simply exported there. If I now go and let's have a look at another project. We open up the Luxembourg project here. This particular project has got some overhead line electrification in. So if we click onto the scan analysis here, Again, you can see we're hinged to the track here, this blue line, and you can see the overhead electrification there. So as we wheel ourselves along the track, we can have a look at the infrastructure there. We can inspect it and zoom in and so forth. So if we choose the overhead line detector tool, and this is a feature that was introduced recently, it allows us to pick on the wire that we want to generate. So if I click on that particular wire there, you can see now it's starting to detect that line automatically, and you can see here it's generating the wire and also generating the position of the catenary poles as well. So we get the mouse position as well as the OLE position. So if we now just pan around, this blue line is now a solid line. So I can wander along it here. You can see how well that's been detected. It's following that point cloud really, really well. And if we just turn around here and head back up the track, you can see it's gone the whole way along the line. You can see the dropper arms there in the background as well as we move past, and as we spin around there, that's all been captured. So I can now choose what line number I want to call it. So I'm going to call this line ML01. I can choose which reference track I want to pair it with, and then I can click on accept. That line has now been generated, and I can close the tool. And now if I click onto ML01 as the overhead line here, I can see the chainage, I can see where the OLE is, I can see where the catenary poles are, and here I can see the heights and staggers. So I can see the point number, the code, the stagger, the height, and the chainage. Now I can add particular intervals if I want to as well. So I've got my start and end chainage of that particular wire. If I wanted to generate a point every 5 meters, I could simply click on add interval. That now has generated every 5 meters along the track, as well as at the catenary poles themselves. And just like in the previous example, I can choose export, and I can say OLE, and that allows me to generate a CSV file with the overhead line electrification on it. If I now go and have a little look at that, just going to have a little look at the OLE. And if we come up here, we can see there the chainage, the lateral distance, the height, and the pole and the point type. So whether it's an interval or the pole, we can see all that information here. And actually, while we're looking at that, we could go and look at the platform, open up that CSV file, same again. And this is the platform information. So again, we've got our easting northing elevation, got the code, so we can see that we've traced it from the shape, track name, we've got the chainage, cant, gauge, and then all these reference distances here to those points as well. Okay. So that's our track detector tool, sorry, our OLE detector tool. If I close this particular project now, then we'll open the final project, and I'll show you our track detector tool and how that works. So if we click on the analysis here, it will show us the scan. So you can see our tunnel here. This is around 1,800 meters of tunnel that we scanned. So the track detector tool up here, number 2, if I click on that, that allows me to generate the 6-foot road here from the main route. So if I choose start from primary track, all I need to do is shift and left click on the rail in the point cloud. That will analyze that and give me a percentage confidence. So you can see we're at 97% there. So if I zoom in, we can see how well we fitted that shape. So you can see that the point cloud here, In fact, if we go and choose the correct track, there we go, we should find it's even better than that. So we're up at 99% now. So we've chosen UIC 60 rail, 99% confidence. You can see how well that's fitted to the point cloud there. And now all I do is choose accept and proceed. So the system now, if we look on here, we'll see the percentage confidence, and the system will just keep going, generating track for us. So you can see it's generated 40 odd meters, 50 meters already. So you can see the confidence that we're running at here, very high, the gauge that we've got, and also the cant as well. So we've generated 100 meters of track already, all automatically. I'll just click stop now. And then if I go back to the perspective view, you can see we're now actually on that generated track. So if I choose save the track, I'll save that there. That track has now been saved up here, and that will allow us then to jump to that track if we want to. So we could now run clearance through here. We could take dimensions from here, and you can see how simple that was to generate that track alignment. And then finally, we can look at our collision test. Now this is where we choose the train profile. We can actually use a 3D wagon if we want to and load its dynamic profile. So with a 3D wagon, we can enter information around the wagon length, wheelbase, end throw, that kind of thing. And you can see on the screen now the profile of that train has appeared. So TfL uses for checking their clearance. So actually, if I go into section view, we can actually run the train down the whole track, and it will colorize the cloud with everything that particular train profile touches. But if we wheel through the track here, you can see now as soon as we're in the tunnel, we're going through at 5 meter intervals. I could actually change those intervals to every 1 meter. So as I mouse wheel along, I'm now going to be going every 1 meter here. You can see that the train isn't going to fit down that particular tunnel. So when we run this algorithm, it will actually push the train through the point cloud. It will colorize the point cloud based on the depth of collision. And it really does help the design team, the engineering team, understand what's going on with the track. And as we saw early on in the presentation, Network Rail have used this to help put new rolling stock on the track and check for any issues. So that's really where I wanted to get to. I think we're getting towards the end of time. What I will just do though is wait and see if we've got any questions. Just bear with me a second. Okay, so we do have a couple of questions to go through. So can you upgrade an existing Gedo to IMS? And if so, how much is it? Well, you can, yeah, you can upgrade an existing Gedo. The very early ones, we just need to check the electronics in there. We do modify the electronics, we do modify the mounting and the brake system. So it would depend actually on the serial number, but I'll be pretty confident that we can upgrade most Gedo to TMDs to the IMS system. The price would vary though, depending on what you wanted to add on in terms of accessories, if you wanted a scanner, that kind of thing. How much does it cost to upgrade Gedo Office software? Again, it depends on the modules that you've got. It can be pretty inexpensive, and we also do different bundles of upgrade as well. So if somebody has perhaps Gedo Vorsys and also Gedo Tamp, we can look at bundle upgrades for that. And if people have got rec and track, we can look at different bundle upgrades for that as well. If you wanted to upgrade to the quality module, for example, that would be an additional purchase rather than an extended warranty. But if you wanted to get in touch, I'll just actually put up our contact details again. So if you wanted to get in touch with Tom or myself, we can help you with that. How do you use the HoloLens with Trimble Connect? Well, the HoloLens would require a plugin to use Trimble Connect. That is a subscription actually to use it. Currently, well, again, it would depend on the number of HoloLenses you wanted to plug in and what you were, what sort of volume of data you were using, etc. But typically around £600 a year for the HoloLenses. Plug-in if you're just using one. One more here. Is a system NR approved? Yes, it is. Yeah, the I mentioned before the Gedo system, and also all our equipment, actually, total stations, control units, laser scanners, all network rail approved. We do have the approval certificate for that, so if anyone wants a copy, I'll be very happy to pass that on. When creating a track alignment in Gedo Scan, can you create a report on accuracy? That's a good question. I've not checked that. You do get the confidence report as you're generating that information, but whether it gives you whether it retains that as a report, I'm not sure. So I will ask that of the guys in the software development team and find that out for you. Okay, if there are any more questions at all, if there are, I'm not seeing them on my screen. If there is anything that any of you think about and want to ask at a later date, please do get in touch. Please do also share the link with any of your colleagues. This webinar will be online as well, probably later on today. So thank you very much indeed for attending. I hope you found it informative, and yeah, look forward to catching up with you soon. Thanks.